and it plays a vital role in proving many problems in mathematics as well as physical science also. Let me prove the Pythagoras theorem using two dimensional shapes, that is squares. With the help of squares, see in right angle triangle we considered squares on each side and we proved the area drawn on hypotenuse is equal to the sum of the areas drawn on the other two sides. See, this is a right angle triangle, a square on opposite side and another square on adjacent side and one more square on hypotenuse. Now, I am dividing each square into unit square, so that we can easily find the area of each square. See, now it is divided into unit squares, that is 16 squares is present there. In this square also I divided entire space into unit squares. Now, what I am doing, I am superimposing these unit squares on the hypotenuse. Now, I am replacing these unit squares and replacing on hypotenuse square. Again this time I am replacing these 3 also, and this time I am replacing, and the remaining one I replace it here. See, exactly it fits the entire area of the square. Therefore, we can say that the area of hypotenuse is equals to the sum of the areas drawn on the other two sides exactly. Now, let me prove theoretically as was given in your textbook. Now, it is I am proving, see, in right angle triangle the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. See, this is a right angle triangle ABC, right angle is at B, and now what I can do? So, I have to prove the square of hypotenuse AC square is equals to AB square plus BC square. What is given? Right angle triangle is given. Right angle is at B. Now, what I have to prove? I have to prove AC square is equals to AB square plus BC square. Now, construction I am taking up, draw a perpendicular from point B to AC such that BD is perpendicular to AC. Now, I drawn a perpendicular BD to AC and it divided the entire triangle ABC into two triangles, and I am just separating this triangle and just I am representing here as it was the mother. See, these triangles I just redrawn from this big triangle, and see here this angle is 90 degrees and this angle is 90 degrees and this angle is 90 degrees, this also 90 degrees, and again this C is common angle in this and in this. Let me show one after the other. See, this is right angle and this angle is C in the mother and this is the angle in the daughter. These two angles, see, this angle and this angle both are equal in these two. Therefore, they are two angles, the two triangles are similar. Similarly, let me show this triangle and this triangle. See, this ABC triangle is similar to BDC. Why? Because angle C is common in both the triangles and angle B and angle D are 90 right angles. Therefore, by using AA corollary, we proved that ABC triangle is similar to triangle BDC. Similarly, triangle ABC is similar to triangle ADB. How? This angle A and this is angle A. In these two triangles, angle B, angle D are 90 degrees and A are common. Same writing, A is common angle, angle B is equals to angle D is equals to 90 degrees. By using AA corollary, we can say that ABC triangle is similar to triangle ADB. Now, I am redrawing the same here, these two set of triangles, mother and first daughter and mother and the second daughter. Then what can we do? We proved that they are similar. Therefore, we can compare their corresponding sides. AB by AD is equals to AC by AB. Then cross multiplying AB, we get AB square is equals to AC into AD. This is first equation, and then I am taking second set of triangles. I am comparing here the corresponding sides BC by CD. See, BC is the adjacent side of this triangle and CD is the adjacent side of this triangle. Now, AC is the hypotenuse of this triangle and CB is the hypotenuse of this triangle. See, I compared these two and I cross multiplied BC. BC into BC is BC square is equals to AC into CD. This is second equation. Now, we get AB square is equals to AC into AD and BC square is equals to AC into CD. These two equations I am adding them up. See what happens if they add? See left hand side, right, the sum of the left hand quantities AB square plus BC square is equals to AC into AD plus AC into CD. Now, AC, my dear children, observe right hand side carefully. This AC here and AC also presented here. Therefore, I am taking common here AC. What is the remaining quantities? I wrote in the bracket AD plus CD. Now, it became AC into AD plus CD. Now, AB square plus BC square is equal to AC square. How? Because this, you observe carefully again. See, this is AD plus DC. AD plus DC whole thing, if we add it up, it becomes AC only. Therefore, AC into AC became AC square. Therefore, we proved AB square plus BC square is equals to AC square. My dear children, we proved Pythagoras theorem in two ways. In first way, I proved by using squares. We proved the area of the square which is on the hypotenuse is equals to the sum of the areas of the squares of the other two sides. Next one, as it was given in the textbook, we proved AB square, AC square is equals to AB square plus BC square. Now, let us solve some problems. It is very important. These problems also we are going to solve in such a way that as we proved the theorem. Now, my dear children, let us observe question which is based on the Pythagoras theorem. See, ABC is an equilateral triangle, D is the point on BC such that BD is equals to 1 by 3 BC. Then prove that 9 AD square is equals to 7 AB square. Now, this is a right angle triangle and this is the point D and this is midpoint E. Given triangle ABC is an equilateral triangle. AB is equals to BC is equals to AC and BE is equals to half BC. Since it is an altitude, we have drawn from the vertices to its opposite side. It is exactly divides into two halves, the opposite side. BC is divided into two halves, that is BE is equals to half BC. Now, it is given that it is trisects, the point D trisects BC. Therefore, BD is equals to 1 by 3 BC. I want to find the small distance this DE. How can we find? If we subtract this from this BE, we get the DE. See, DE is equals to BE minus BD. Now, DE is equals to BE is equals to half AB, no? Half AB minus 1 by 3 AB. If you take LCM, DE is equals to 6 is LCM and 3 AB minus 2 AB. What it becomes? DE is equals to 1 by 6 AB. Remember this and we have to use this in our calculation. See, this is DE is equals to 1 by 6 AB. Now, in consider triangle AEB, this AEB and AED. See, this is AEB and this is ADE. Now, I am considering these two triangles only to prove the required result. Now, see, in right angle triangle ADE, we can write AD square hypotenuse, AD square is equals to AE square plus DE square. This is first equation from this triangle. ABE, in this triangle ABE, we can write it as AB square is equals to AE square plus BE square. This is second equation. Now, subtracting 2 from 1, if I subtracted, what happens? This will be gets cancelled, AE square will be gets cancelled, and the remaining terms I am writing here, AD square minus AB square is equals to DE square minus BE square, DE square minus BE square. Now, I have to prove this in terms of AD and AB only, and then I am converting every term in AB and AD. See, AD square minus AB square is equals to DE square minus BE square. DE, we proved that it is DE is nothing but BE minus BD whole square minus BE square. From here we started this, every term I am converting into AB and AD, and it is AD square minus AB square is equals to DE in terms of AB, I wrote AB by 6 whole square minus BE is AB by 2, because it is BE is half of this BC, BC is nothing but AB. Therefore, I wrote BE as half AB whole square. Then I am simplifying it, AD square minus AB square is equals to BC square by 36 minus BC square by 4. See, it is an equilateral triangle, all angles are, all sides are equal. Therefore, I can write this BC as AB, AB square by 36, and this is also AB square by 36. This is AB square by 36, AB square by here 4, here 36. Now, this is AD square is equals to BC square by 36 minus BC square by 4 plus AB square. Now, again in the next I am converting this BC as AB, since this BC, this is an equilateral triangle, BC is equals to AB is equals to AC, no, that is the reason I wrote BC as AB and BC, this also AB, and this is AB keeping as it is. Now, it became AD square is equals to 36 AB square plus 1 37 minus 9, 37 minus 9 by 36. It became AD square is equals to 28 AB square by 36. Now, dividing numerator and denominator by 4, we get AD square is equals to 7 AB square by 9. See here, by dividing 4 7s are 4 9s are, and it became 7 by 9. Cross multiplying, we proved 9 AD square is equals to 7 AB square. Hence, it is proved. My dear children, we have proved 2 problems using Pythagoras theorem, and one more problem, it is very typical and it is very easy if you understand or if you redraw the triangles which involved in the main triangle becomes very easy. Let me show the next problem. In right angle triangle ABC, if D and E trisect BC, then prove that 8 AE square is equals to 3 AC square plus 5 AD square. See here, ABC is a right angle triangle given, and DE trisect means they divide in 3 equal parts. Now, I am considering this triangle and this also another triangle. Let me redraw them. First 1 by 3 BC, DE is equals to 1 by 3 BC, and EC also equals to 1 by 3 BC, and BE is equals to 2 by 3 BC. Now, ABC is a right angle triangle at B, and D and E are the points of trisection of BC. Therefore, I am writing BD is equals to DE is equals to EC is equals to 1 by 3 BC. Now, BE is equals to 2 by 3 BC, because BE is 2 by 3 BC and BE is equals to 2 by 3 BC, I am rearranging the terms like this. See BC keeping this side, and this fraction if it goes that side, it becomes 3 by 2 BE. Remember very well this is the star step in doing this entire problem. See BC is equals to 3 by 2 BE and BD is equals to 1 by 3 BC, and I am replacing BC with this term 3 by 2 BE, and it became 3 and 3 will be gets cancelled, 1 by 2 BE. BD is equals to, this is half BE, and here in triangle ABE, what can I write by using Pythagoras theorem? AE square is equals to AB square plus BE square. AE square is equals to AB square plus BE square. Now, I am multiplying this, I need 8 AE square to be shown. So, I am multiplying both sides by 8. It became 8 AE square is equals to 8 AB square plus 8 BE square. This is the first equation from this triangle ABE. Now, I am taking one more triangle ABD, this is the yellow colored small triangle, and here redrawing there, it is hypotenuse. What can I write? AD square, hypotenuse square is equals to opposite square plus adjacent square. AD square is equals to AB square plus BD square. Now, how many AD squares I want? 5 AD squares. So, I am multiplying entire thing by 5 later, and now BD I am replacing as 1 by 2 BE, 1 by 2 BE, and what it becomes? 5 AD square is equals to 5 AB square plus 5 into 1 by 4 BE square. This is second equation. See here also I multiplied entire equation by 5. Now, continue. The 3 equations I have written from the back slide, and I am continuing proving this problem. I am taking now ABC. In triangle ABC, AC is hypotenuse and AB and BC are other two sides. AC square is equals to AB square plus BC square. Now, AC square is equals to AB square plus BC. I am replacing, just now I showed you BC as here like this, BC as 3 by 2 BE. BC is equals to 3 by 2 BE. I am substituted BC is equals to 3 by 2 BE here. Now, after simplification it became AC square is equals to AB square plus 9 by 4 BE square. Now, I need to prove 3 AC square. I need 3, I am multiplying entire equation by 3. What happens? It becomes 3 AC square plus 3 AB square plus 3 9s are 27 BE square by 4. This is third equation. Now, I am just comparing these 3 equations here, I brought it. Now, adding 2 and 3, this equation and this equation, what we get? This 3 AC square in left side plus 5 AD square left side. I wrote 3 AC square plus 5 AD square. What is the right side quantity? 5 AB square. This is 3 AB square plus 27 BE square by 4, 3 AB square plus 27 BE square by 4. Now, plus this 5 AB square plus 5 by 4 BE square. Now, 3 AC square plus 5 AD square is equals to 3 AB square plus these two are like fractions. See, this is 27 by 4 BE and 5 by 4 BE. I am just adding, rearranging these terms here, and I am writing 5 AB square here. Now, what happens? Here, without changing anything on left side, I am writing as it is 3 AC square plus 5 AD square as it is, and it became 3 AB square plus 5 AB square is 8 AB square, 27 plus 5 is 32, 32 by 4 BE square. Now, cancel 4 and 32. It became, by cancelling 4 and 32, what it becomes? 4 1s are 4 8s are. It also become 8 AB square plus 8 AE square on right side. Now, from equation 1, 8 AB square plus 8 BE square is equals to what? 8 AE square. I am replacing this entire thing with AE square. See here, 3 AC square plus 5 AD square is equals to 8 AE square. Hence, it is proved. And let us prove one more very important problem which comes usually in your examination. See, O is any point inside the rectangle ABCD as shown in the figure. Prove OB square plus OD square is equals to OA square plus OC square. This is also very important problem using Pythagoras theorem. See, this is the rectangle ABCD and O is any point inside, and we have to prove OB square plus OD square is equals to OA square plus OC square. Then through O, draw PQ parallel to BC, so that P lies on AB and Q lies on DC. Now, I am drawing a line PQ parallel to BC, PQ parallel to BC and PQ, naming P and Q there, and P lies on the side AB and Q lies on the side DC. Now, consider many right angle triangles are evolved. From this, I am taking the small piece of right angle triangle OPB. PQ is parallel to BC and therefore, PQ is perpendicular to AB and PQ is perpendicular to DC. Therefore, it is 90 degrees. See, I am taking this small piece here, I am dragging it here and I am rearranging and kept as right angle triangle, and by using Pythagoras theorem. See, so BPQ is 90 degrees and CQP is 90, CQP is also 90 degrees. BPQC and APQD are both rectangles, this and these also are rectangles, and I am considering this triangle OPB. By Pythagoras theorem, in triangle OPB, OB hypotenuse square, OB square is equals to BP square plus OP square, BP square plus OP square. And next one, I am considering one more triangle. This is similarly OQD, this triangle OQD, what can I write? OD square is equals to OQ square plus, see, this is OD square is equals to OQ square plus DQ square. Next, in triangle QOC, this is QOC, what can I write by using Pythagoras theorem? OC square, this is hypotenuse, Pythagoras theorem, this is hypotenuse, OC square is equals to OQ square plus CQ square, this is third equation. Now, I am considering this triangle also OPA, OPA. Now, in triangle OPA, OA is hypotenuse, OP is opposite and AP is adjacent. I am writing OA square is equals to AP square plus OP square. Then I am taking these all 4 equations into next slide, these 4 equations. Now, this adding 1 and 2, this first equation and second equation, what we get, you see, OB square plus OD square. See, in 2 right angle, in these 2 equations 1 and 2, OB square plus OD square is equals to BP square plus OP square plus OQ square plus DQ square. See here, OQ square plus CQ square, OQ square plus CQ square is equals to what? See, this is rearranging these terms, we get OC square plus OQ square plus AP square plus OP square. See, since BP is equals to CQ and DQ is equals to AP, because these are opposite sides of the rectangle, therefore, we write BP as CQ and DQ as AP. Now, it became CQ square plus OQ square plus OP square plus AP square. Now, right hand side only I am changing, left hand side I kept as it is, and here from third equation OQ square plus CQ square is equals to what? Here I am replacing this entire thing, this with OC square, this is with OP square plus AP square with OA square. See here, OC square plus OA square. Now, hence proved the left hand side OB square plus OD square is equals to OA square plus OC square. OB square plus OD square is equals to OA square plus OC square, hence proved. My dear children, till now we have proved Pythagoras theorem in two ways, and we solved some problems which is related to Pythagoras theorem. My dear children, we have learnt Pythagoras theorem and its applications in this session. Bye, and let us meet in the next session with other topics.